Alright, so I think this is recording. Let's try to match these log equations to their graphs, and we have to remember our transformations that we learned way back last semester, I believe, in Skill Packet 2. So let's, if I look at these equations, this log base 4 of x, when I then go on to number 11, that's a transformation of the graph of 10. Number 12 is a transformation of a graph of 10. Number 13 also is a transformation of the graph of 10. So if I can find the graph of 10, that's going to be crucial for me to recognize, because then from there, that's where I'm going to do these modifications, these transformations on the graph. So what am I looking for in the graph of y equals log base 4 of x? Let's look at just a few points. If 4 raised to the negative 2 power would be 1/16, so 1/16 comma negative 2 is on the graph. 4 raised to the negative 1 power is 1/4. 4 raised to the 0 power is 1. 4 raised to the first power is 4. 4 raised to the second power is 16. So it's probably, these exponential functions, these log functions, change pretty quickly. Well, at sometimes quickly or sometimes slowly. These 2 points should be enough for me to narrow down my search and find what this graph looks like. So let's come over and see if we can find it. So when I compare these first graphs here, this one's 1, 0, this one's 4, 1. It looks like I've gotten lucky and found it right off the bat with graph A, because graph B is going in the wrong direction. Graph C is too high. So right now I believe that this is going to be A, but let's alright, this 4-1, this graph's not going through 4-1, this is going the wrong direction, this has been flipped, so it can't be these. So A is looking better and better as I just double check that it can't be one of these others, because see, I'm just basing it on those 2 points. If I have to go and look at more points, I can. This is 4, 0. Well, 1, 0 was our x-intercept. This has been shifted to the right, this has been shifted to the left, so pretty confident then that this first one is going to be the graph of A. Alright, so now that I know that to be thinking about transformations on the graph of A, this negative sign is a reflection across the x-axis. So this 4, 1 is now going to be 4, negative 1. The x-intercept is the same. But I'm looking for a graph that looks like this. So it's not B or C. It's not D, E. It could be F. It's not G. It's not H. It's not J. So F. You can see that F looks to be even just my rough sketch. I almost hit it there exactly. So this guy is F. Now this negative sign that's in front of X is a reflection across the y-axis. So instead of 1, 0, we've got negative 1, 0. This is coming down like this. And instead of 4, 1, we've got negative 4, 1. And it's going off and looking like this. So I can't see what C looks like. Nope, C is not it. D is not it. And what about E? he looks to be like a candidate because it's negative 4, 1. It's definitely not F, not G, not yeah. So this has to be E. So now this plus 4 is actually a transformation of the graph of A, but you don't move it to the right 4 units, you actually move it to the left 4 units. So 1 minus 4 is a negative 3. So I'm looking for something that looks like that. It's been a shift to the left 4 unit. Yeah. So something that looks like that. It's not D, it's not E, it's not F. It looks to be J. That we've shifted it to the left 4 units. All right, this minus 4 is going to be a shift to the right 4 units. So this x-intercept of 1 has been shifted to the right 4, so it's now at 5. Let's see. It can't be one of these three, D, E, or F. That's not been shifted. Look at H there. H looks like it's been shifted. And yeah, this is H. Now, 16, that's not a horizontal stretch. That's a horizontal shrink. So this is gonna shrink in towards the y-axis. Well, there's no part of the graph that's over here in quadrants 2 or 3. So this graph is horizontally shrinking towards that y-axis. That 1, 0 is going to be 1/16, 0. So it has the same shape. It's just been really, let's see if I can, it's been really scrunched in horizontally. All right. It's not D, E, or F. What does C look like? There we go. Right here, it almost looks like it's going through the origin. Well, 1/16 is going to almost look like 0 to us. So to me, the clear-cut choice, I think, is going to be C, because these others aren't close enough to the origin. Right, so it has to be choice C. Alright, so where's the rest of our... Alright, so now these three, let's move this over to the side. Alright, this 1 over x, remember that we can rewrite that right now this exponent is 1. If I change this x up to the numerator and have this be x divided by 1, then I have a negative exponent here, and by what we will learn to be the power rule, this negative sign will come out in front. So even though 17, this equation doesn't look anything like number 11, these equations are the same, and they have the same graph. So 17 has to be F. This 4 is a vertical stretch. So let's look at the graph of A, and if we stretch this vertically, it's like that. But let's see, like this 1, this 4, 1 is going to be 4/16. So let's see. I don't see that though. I'm taking the y coordinate the output and multiplying it by 4. Let's look at this again. So I'm not 4, 6. This 4, 1. If I take 1 and multiply it by 4, I'm looking for the graph that passes through the point 4, 4. So it's this graph that's been vertically stretched, and this 4, 4, this is the graph of C. So how can I argue that 18 and 15 are the same? I'll have to look at that later and try and give you an answer. Alright, so here this has two transformations. You might want to rewrite this as log base 4 of negative x plus 2, because this has been shifted to the left 2 units and then reflected across the y-axis. So let's move these graphs over. If we take the graph of A and we move it to the left 2 units, it'll look something like this. And then if we reflect that across the y-axis, it's going to look something like this. Alright. Can't be G, H, or J. Doesn't look like. Oh, there it is right next to it. It's right here in B. I was scooting around looking at that and I couldn't see it. This purple line right there is the graph of B. Sorry about that. It's kind of early in the morning. I haven't fully woken up yet. Alright. Now, this minus 1 is a shift down 1 unit. So it's taking the graph of A and shifting it down 1 unit. So let's go back and look at A. So if this is shifting down 1 unit, at 1 we'll be at negative 1. You know, it's looking like this, where it's been shifted down 1 unit. So looks like it's G. What was at 1, 0 is now at 1, negative 1. So this guy looks to be the graph of G. By the power rule, this 4 is going to come out in front. So whatever my answer is on 21, it's the same as 18. See, I'm now beginning to question this 15, but I'll have to maybe come back in another video. It's possible that I could have accidentally not had the correct graph for that among these choices, and it just kind of looks in general shape enough to make it to fool us into thinking that it looks like this. Alright, if I have the addition of two logarithms, I can write it as a single logarithm with multiplication. So this is log base 4 of 16 times x. So this is going to be the same as 15. So this 22 is going to be the same answer as problem number 15, which I need to double check and see whether that's actually C or not, if I've made a mistake or not. But this one and this one, I know definitely are going to be the same graph. Whether it turns out to be choice C or not, I have to double check. Log base 4 of 1 is just 0. Because 4 to the 0 power is 1. So this is definitely the graph of A, because with this being 0, 0 plus log base 4 of x, that's that. This plus 2 is a shift up 2 units from the graph of A. So this looks to be the graph of C, possibly. And yeah. Okay, so I'm pretty confident that this would be the graph of C. Now, if I rewrite this 2 as log base 4 of x and 4 raised to the second power, this is 16. Yeah, okay. So I am convinced then that these are C. Now, what about 18 though? So I know, I'm pretty confident by my properties of logarithms that these three are definitely the same answer. Now, x to the 4th, it's this number 18 that I'm now thinking about. That was a vertical stretch of a factor of 4, but with properties of logarithms, I think that when in the small window that we have, especially when it's y is equal to 2, 4 squared is 16. 16 times 4 is 64. I think that this guy was the one that's technically not on there. All right, so I'll worry about that later. Hopefully, I haven't confused you thinking out loud and thinking through this. The others are definitely right. So, hope that helps, and I'll talk to you later. Bye.